How to model the jaw screw using SolidWorks. Hi, Joe Cerrone. Today we're looking at this assembly model of a vise, and we're going to model this jaw screw. If I right click on my assembly, I can open the part. We can take a look at that part, how that part was created. Again, we can use the Wayback Bar to bring this back and to see how the part was created. And so it was created from a sketch and revolved around the center of the part. And so there's not a lot of steps to creating this part. We start off on the front plane, and if I right click on the eyeball, I can see that that goes right down the center of it because it's a revolve. If I want to see where the other planes are located in relation to that, I can right click and show that and that. And so you can kind of see how the designer worked on this part. You'll see that the origin is over here at the left end, and then everything is kind of worked off of that, and it's modeled right down the center. So let's get started on that. If we look at the print, we have this jaw screw, and it's a drawing in millimeters. If we look at the diameter values, we've got 12 millimeter diameter, an 8 millimeter diameter, and then we have a 16 millimeter diameter. That's kind of the overall length of it here. This part we could actually look into using the thread wizard and cutting a 16 millimeter thread on here and actually try printing it with threads. Everything else is pretty straightforward. If we look at how this part would function, we can take a look at our assembly drawing. And when we look at the assembly drawing, if we were to thread this, we can go back to our vise jaw and also thread this hole here. And then when we 3D print it, we can add a mechanical mate, and it will actually simulate the thread representation. You'll be able to actually unscrew it and screw it together. So let's get started. We're going to start a new file, new, part. Okay, it's a metric drawing, millimeters. I'm going to start this on the front plane. I'm going to right click, start a sketch. I'm going to draw a line, and that's going to be about 138. It's going to be a horizontal line. And then I'm going to draw the basic profile with the origin being here. I'm just going to move up and around, create that shape. And then we're going to revolve it. Probably could have gone to the end since I haven't defined any of the values, but we can add those as we go. So that's the basic shape profile. Now let's tie it down with some dimensions. And so we can come in here with smart dimensions. And then if we dimension from here to here, and rather than calculate, I was hoping that I would get the ability to do diameter dimensions, but it doesn't seem to want to do that with a regular line. So to turn a line that you've already created into a construction line, what you can do, I'm going to bail out of this by hitting escape, select that line, and then I'm going to click on for construction. And I think that's what it wanted for me to do the dimensional values that I wanted. And so if I want to go and dimension these as diameter, yes, I can do that. And so that's going to be, it takes the math out of it. And I've never been a big math person. I blame my high school math teacher. I had good teachers, but a lot of them were coaches. And anyway, so this will be 12 millimeters. And I'm not saying that that's bad. I'm just saying my math is my math. All right, and so let the computer do the work. If you put a center line down the middle, I don't have to cut everything in half. That's one of the reasons that machinists' values are usually dimensioned in diameter. We don't want the guys on the shop floor to have to do math if they don't have to. If you put the numbers on the print, then just follow the numbers. It keeps it simple. So we have the diametrical values. I've got a couple of blue lines here that I want to make collinear. So if I want to get this value here according to my print, this line right here is even, and that's 12 millimeters. So I'm going to add a relation. Adding a relation is part of the design intent. Sure, I could go in there and put a 12 millimeter diameter dimension on that, but when you get into design intent, this is better to set this up as collinear, because what this actually does here, the function of that, is to hold the vice jaw that slides back and forth with the screw that comes down through the top. And so this part's going to go right in here, and then we're going to thread this fastener, and the fastener is going to hold the jaw to the jack. Okay, so I have my diameter values. Let's go ahead and add the horizontal numbers. And this is quite common. Sometimes you'll have to move these numbers or move these sketches, and you can just kind of grab them. It's pretty fluid while they're blue. Hit escape. Neatness does count. So as you work on these, once you kind of have things on there, it's appreciated when somebody kind of buttons things up and makes it look nice. You kind of want to go with sort of a kind of like rays radiating out from the sun. You kind of want to have the dimensions kind of built up from smaller to bigger as the part is created. There we go. And then we just have a couple more dimensions that we need to add. I guess that was the only one, 138 millimeters. Okay, everything's fully defined. Let's revolve the part. And so we're going to go to Features, and we're going to say Revolve Boss Base. And since we turned this center line into a construction line, we're going to have to agree to close the sketch. And so we'll say yes, because we don't want a thin feature. We want this to be a solid part. Think of a thin feature of like an eggshell. And so that will fix what we need. We'll green check mark it. And then the last component we're going to need on this part is that hole. Well, I guess there's a couple components. So let's take a look at, let's look at the threading component first. To thread this part, if we look at the print, the diameter of the jaw screw is 16 millimeters. And so to figure out what size thread to put on here, we're going to look at the Thread Wizard chart. So switching back over to our part here, we can go to our Thread Wizard. And this is just a warning. I think SolidWorks puts that on there because some of the parts that people make are very expensive, and they kind of want to say, hey, this is a warning that thread tool type profiles are nominal. In other words, they're kind of basic. The Machinist Handbook is a great way to see all the nuts and bolts about it. But as far as this goes, SolidWorks is really good. It's just a warning, and I think they just do it to cover themselves. If we look at the thread location, we'll thread it from here, or we can thread it from here, either side. Now I'm going to go from this side right here, and then I'm going to choose the thread type, and so I'm going to go with a metric die. Now what's the difference between a tap and a die? A tap is used for holes, and a die is used for rounded shapes or cylinders. So we have a cylinder, so we're going to go with a metric die. And then we're going to look at what our values are here, and we're going to find an M16 by 1.5. And let's take a look at how that looks. And then we'll set that up with a offset, and we'll set that length It says up to selection. I'm going to say blind. And then I'm just going to build this up. If it wants to cooperate with me. Doesn't. Maybe it's just me. Here we go. It looks a little too far here, but if we use the offset tool, and we offset it the other way, and let's offset that a little bit more. Not that much. Let's go with 5. This is how we cut threads on a lathe, where you'll have a relief, and then as the machine turns the part down, it goes into these run out areas, and then it retracts, comes down, cuts a little deeper, retracts, comes down. So this looks good. Green check mark it. And now we have a threaded jack screw that we can actually print. A lot of times what I'll do is I'll print these, and then I'll run a die over a metal die, or you can just get a nut or a bolt, actually a nut, and thread a nut onto it, and it'll straighten those threads out. Because remember, 3D printing prints in layers of plastic. It's, you know, 0.2 millimeters, 0.3 millimeters, depending on how you have the fineness of it set. So it's often needs to be tweaked. Now the last thing we need to do is put a hole in this part. The easiest way to do it is to use one of the planes and just to drive that through. So I'm going to spacebar and go and take a isometric view. I'm going to show my front plane, and I'm going to make it on the front plane, and I'm just going to go right down the middle and make a hole mid-plane. And so I'm going to say create a sketch, spacebar, normal 2, sketch, circle, and I want this circle to be down the center, so maybe what I'll do is I'll put a center line first, just to make sure. And then I'll go on this center line. And it's a 6 millimeter diameter hole. Ideally, as I'm looking at this, I would make it 6 plus a 32nd, because the designer, and it's often true on a lot of these CAD books, they'll create parts with geometry on geometry. And what I mean by that is having a 6 millimeter hole and then having the screw bar that goes into that also 6 millimeters will be the same exact size. It won't slide into that hole. So the machines are very precise, and typically I make holes a 32nd over size to have some clearance. So we could make this maybe an extra 10 thousandths, and so I could say and then I'll locate this dimension . 12. Features, extrude cut. And what I want to use is mid-plane. And then I want to just build this value up so it goes all the way through. Okay. Save it. Add some color to it. Save it again. And that completes this exercise for creating the vise screw jack.